Yesterday we looked at email, and that was fairly easy to send, really hard to receive, but you don't generally receive, so that's okay. Today we're going to look at channels and search, so public channels in the morning and search in the afternoon. So yesterday afternoon I talked about how we could have added real-time updates with using polling. So here's the idea of a poll. So I have a computer over here. Here's my laptop. It has a browser. And over here I have App Engine. So inside here is my Go app. And he makes API requests. So he goes to /API /tweets. Maybe he passes in username. Whatever. And he does this, and then he replies with the list of tweets, so you get, text. And he does this over and over. So this is how polling works. So this is, and so every, if this is done at, let's say 1 o'clock, this is done at 1:01. 1:02. We're doing this over and over, okay? Back and forth. And most of the time, the data returned is exactly the same. And it only changes when some new tweet shows up, right? Everybody understand the basic idea of polling?
So when a client is looking at somebody's tweet feed, like I'm at Caleb's tweet page and hear all your tweets, I'm looking at that from my client machine, but then every now and then the client's talking to the server, saying any new tweets from Caleb, if there's a new tweet, then on my machine after it responds back, there's a new tweet, it'll show that, right?
Yeah, it'll show.
Yeah.
But this is the polling example. It's actually making an API request every single time to get the list of tweets. Okay. And so then this gets done with JavaScript. Oh, now it looks different, so I'll show that. So one improvement to this is what's called long polling. Does anybody know what long polling is? Okay.
Helpful when the water gets deeper?
So long polling is very much the same. We have our laptop ready. Except now we have at 1 o'clock makes this request. And he passes, API tweets, username.
Oh, I bet that it calls it, and the server holds the request and only replies when there's a new tweet.
Exactly. So we'll say last update. Equal whatever. And what will happen here is it will eventually reply maybe at 1:00 or 1:10, 10 minutes later. Now, whatever it is, it's some period of time later with the data. Okay?
But only if there's
But only if something has changed, right? So this is an improvement because instead of the 5 requests, I can make 1. But the downside of it, well, what's the downside?
you've got as many requests waiting as you have current users.
Yeah, so you have tons of these really long live requests on the server. Okay,
Connections open?
they're just, sorry, what?
You have public connections open?
Yeah, you have to have all these connections. In particular, on App Engine, you're limited to 60 seconds. The longest a request can take is 60 seconds, and then App Engine, their front-end load balancer will kill the request, okay? Because they've assumed that you've done something terrible, and so it'll stop. That's not unique to App Engine. That's very typical for load balancers. Because HTTP requests are supposed to be stateless and very fast. And this is turning them not as stateless because now we're passing state around. And now they're really slow. These requests take forever. But this is a much more efficient solution because you don't have to do all these back and forth requests. And you get the update when it happens. The downside of this is if the update happens between 1:01 and 1:02, it takes takes me up to a minute to see it. Okay? But here, I'll get it as soon as it happens, or very near to that. And so long polling can improve that. But like I said, it has some downsides. These days, you can do an even better one, which is a WebSocket. Okay? And a WebSocket is, so we have our computer and we have our app engine, is a fully bidirectional communication. So now we have a socket. And what that means is the connection is living for just as long. So it has that same open connection, except now we can send and receive data during the entire lifetime of the connection. So the difference between this and this is here I'm having to make a new connection each time. And here the connection's already running. Okay, and so this is just like when we did TCP servers with Echo and all that, that's what this is. Okay. And so you can use the WebSocket to make a real connection and then communicate both ways over that connection. And this is better than this, but it still has the downside of, well, once you've gone this route, now all of the existing HTTP stuff is you've thrown it out. Like load balancers don't understand this at all because they thought you were communicating via HTTP, and now you said, forget HTTP, we're moving back to TCP. And so it's like, I don't know what to do with requests that look like that. So you cannot do this on App Engine. So I'm going to cross through. So this is not an option on App Engine, okay? You cannot do a WebSocket, it won't work.
Just a momentary interruption. Make sure you have your parking passes in. I see parking police out there. Go.
So what we can do instead is they have an API for channels. And the idea of a channel is that it's something like this or this underneath. For us, it's an API, it's an abstraction. We don't really care how they implemented it. But it allows us to do, so in other words, this doesn't work great on App Engine because we can only hold for 1 minute, and having a ton of connections is a problem. This doesn't work at all on App Engine, but this we can use to substitute for this approach. So we can beat our polling API as the channel. Okay, everybody follow? So how does the channel work? So we have our laptop, and the first thing we do is we say, create a connection. So we'll say that's create a channel. That's the first thing we're going to do. So he's going to go over to the server. What this is going to do is going to call the create function inside of the channel package. And we'll look at that, what that is. But he's going to hand back a token. So this is Google over here. This is their API. Call on create, and we get back a token, and we give that token back to the client. And then in JavaScript, he's going to open the channel. So he's going to say open. Well, he's going to create a channel with the token, right? And then he's going to open. Okay. And then we're going to have a bunch of event handlers on open, on message, on close, on error, and we can also. So in general, the process is going to look like send. And the send is something like /API/whatever. This is a thing we invent, some JSON endpoint. He's going to send data if he wants to send a message. That's going to go over here and call send to Google. Okay? And that's going to end up sort of bypassing our server and going straight to the client and handing them the data. So it's going to trigger this on message or whatever with the data that was sent. Okay. And following the flow here, I create a channel, get a token. I create the channel on the client side, and now I'm connected to Google over here. And now when I do a send, it goes all the way over. So the client gets the data. And so this send doesn't have to come from this client; it can come from lots of clients. But this client will receive it over his channel. Okay. The basic flow is that the client initiates the creation. In the Go code, I create a channel, hand back a token. And that's what the client's going to use to communicate with Google, is that token. And then anytime I send a message on GoSide to this channel, the client's going to receive it. So I'm not sending to the client. I'm sending to Google, who then sends to the client. And I'm using the channel ID. There's a unique name for the channel to know where it's going. Okay.
What's that one send? When does that occur? Right between the client and our code in the middle.
This send.
Yeah.
So actually, maybe I'll draw it differently, just so we can get this clear. Imagine we have another client up here. He does the send.
Oh, right. Okay, got it.
Send.
Yeah.
That's the-
Cool.
But he can send too. He can send
Yeah.
himself. But
Yeah.
generally, you're going to send to him. The point is actually, it doesn't even have to be initiated by the client. This function, send here, is what triggers the
Yeah.
function. So this could actually be the result of the server doing something. So the API is small, but it is a little hard to wrap your head around the process because there's three different systems in play. There's the client, there's the server, and then there's Google.
Yeah.
And we're communicating with the client for some things, but then the client's communicating with Google for other things. And so we have to keep track of what's going on. But the API is very small. It's create and send, right? And then on the server, on the client, it's also like a new channel and it opens. So there's only a few things involved, but it's, you have to wrap your head around it. And I think maybe looking at an example will make it more clear. So any questions about the basic idea here?
So on the client, you have some sort of a listener, like a JavaScript listener, waiting to see if.
That's right. He has a bunch
message is
of on whatever event handlers.
That's nicely laid out. Thank you. I'm gonna save that diagram.
Okay. I have to erase this because the screen leave the screen. And like I said, this is very similar to how WebSocket would be. So if you learn channels, you kind of understand the same approach you do with the WebSocket, which has more general use because you can use that everywhere. And WebSockets is like really cool new technology everybody wants to know how to do. So.
One of the scaling problems with WebSockets.
Yeah, so the scaling problems are that the load balancer technology is not designed for it. And
Well,
so,
one of them is that the number of TCP ports is fixed. So the big boys, that's a limiter. They actually run out of TCP ports because you need a port for each socket.
How many ports on a
I
server?
think it's 65K.
yeah, 64,000.
Yeah. And so
So
Twitter and people, they actually,